Welcome everyone to today's Explainer. Get ready because we're about to dive into something truly fascinating. We're actually combining two things you probably wouldn't expect to see together: the hard, mathematical physics of motion and some deep, time-tested philosophical wisdom. So whether you're an 8th grader looking at these formulas for the exact first time, or honestly just someone wanting to sharpen up your mind, you are absolutely in the right place. Today, it's all about calculated motion. We're going to figure out how to measure the physical world around us, and more importantly, how to apply that exact same careful calculation to the everyday choices we make.
Okay, let's dive into this. The source material from the Godly Learners series points us to Psalm 90, verse 12, which says, "Teach us to number our days, that we may gain a heart of wisdom." Now you might be wondering, why start a physics explainer with a Bible verse? Well, it's because the source emphasizes that God actually values careful calculation and wise planning. I mean, think about it. The universe isn't just random, right? It's built on order, logic, and these incredibly precise mathematical laws. So when we learn how to solve motion problems, we're actually practicing that exact same careful calculation. We're learning to look at the variables right in front of us, figure out how they interact, and then predict the outcome. It's like a giant puzzle where valuing the math perfectly mirrors the wisdom we need to navigate our daily lives.
So here is our roadmap for today's explainer. First up, wisdom in calculating motion. Then we'll hit the formula for acceleration. After that, some real-world physics examples, followed by a test of your physics knowledge, and finally, we'll wrap up with education combined with morality. Let's get right to it. All right, Section 1, Wisdom in Calculating Motion and Why Math Actually Matters in the Real World.
I want to make something super clear right up front. We are definitely not just memorizing numbers today. We aren't just shifting letters around on a page. Calculating acceleration is a genuinely powerful tool for safely and intelligently navigating the physical world. I mean, when automotive engineers are designing the safety features for the cars we all drive, what exactly are they doing? They're calculating acceleration and force to design safer vehicles. And when scientists are, say, trying to land a rover on Mars, they're using these exact same principles to plan their experiments and solve massive, real-world problems. But hey, even if you don't grow up to be a rocket scientist, learning this stuff absolutely builds crucial critical thinking skills. It basically trains your brain to stop and say, okay, if I have this amount of force and this amount of mass, what's going to happen next?
So here's exactly what you'll be learning today. By the end of this explainer, you're going to know how to take that famous physics equation, F equals ma, and rearrange it to solve for acceleration. You'll also figure out how to use the correct scientific units because, let's be honest, numbers without units are just floating out in space. And perhaps the coolest part, you'll learn how to look at your final answer and double-check if it actually makes logical sense.
Moving on to Section 2, the formula for acceleration. We're going to be breaking down F equals ma. All right, it's time to roll up our sleeves and really get into the physics. Now, don't let the letters intimidate you. This is going to make perfect sense once we break it down. So the crucial point is this formula right here. A equals F divided by m. You've probably heard of Sir Isaac Newton's famous second law of motion, right? F equals ma, meaning force equals mass times acceleration. Well, to figure out just the acceleration of an object, we just use a tiny bit of basic algebra to rearrange that equation. We just divide the force by the mass. And boom! That leaves us with our magic formula for today. Acceleration equals force divided by mass. It really is that simple. It's just how hard something is being pushed divided by how heavy and bulky it is.
Now, if you want to get the right answer every single time, and who doesn't, you just need to follow 3 exact steps and strictly obey the unit rules. Step 1, find your force, and make absolutely sure it's measured in a unit called newtons, which we represent with a capital N. Step 2, find your mass, and ensure that's measured in kilograms, or kg. If you divide those newtons by those kilograms, step 3 just happens automatically. Your final result for acceleration will always be in meters per second squared. And you know what that unit tells us? It tells us exactly how many extra meters per second of speed the object is gaining every single second. Just stick to these units and you literally cannot fail.
Okay, on to Section 3, real-world physics examples. Let's put this math to work.
Let's take that abstract formula we just learned and see how force and mass actually interact out in the real world. Now, what's really interesting about this slide is when we start comparing these different objects. Just look at the first row there, a soccer ball. If we apply a pretty small force, just 10 newtons, to a super small mass of half a kilogram, well, 10 divided by 0.5 gives us a massive acceleration of 20 meters per second squared. That ball is going to absolutely zip away. But now check out the small car and the sled. The car has this huge force of 4,000 newtons pushing it, while the sled only has 200 newtons. But because the car's mass is so much larger, we're talking 1,000 kilograms compared to the sled's 50 kilograms, when you do the math, they both end up with the exact same acceleration, 4 meters per second squared. The massive weight of that car resists that huge force, perfectly demonstrating how mass directly limits acceleration. Pretty wild, right?
Next up, Section 4. Test your physics knowledge. It's time for the homework challenge.
All right, you've seen how it works, and now it's your turn to prove what you've learned. I highly encourage you to pause the explainer right now, grab a pencil and some paper, and work your way through these 4 equations. For numbers 1 and 2, you're just finding a, the acceleration. Keep that formula in mind. A equals F divided by m. Now for numbers 3 and 4, I definitely threw a little twist in there. You're given the acceleration, but you need to find either the force or the mass. To solve those, you're going to have to think back to that original F equals ma equation. Take your time, calculate carefully, and just remember the steps we literally just practiced. You've got this.
And here is the 5th and final homework question for you to really ponder. Why is it important to use correct units in your calculations? I'll give you a bit of a hint. Telling someone to drive 50 doesn't mean much, right? Is that 50 miles per hour, 50 kilometers per hour, 50 meters per second? The unit is what gives the number its anchor in reality. In physics, if your units are wrong, your reality is just totally off. So, the why and the how of these units are just as important as the final number you end up circling at the bottom of the page.
Finally, Section 5, Education Combined with Morality, covering the heroesmartacademy philosophy.
So we've learned some really excellent physics today and sharpened our minds, but the curriculum asks us to step back and ask a much bigger question. What do we actually do with this educated mind? We're basically facing a crossroads. On the left side, we see education without morality. The source argues that you can know all the physics in the world and you can be absolutely brilliant at calculating force and mass, but if you lack a moral compass, that intellect often just leads to making bad choices that end up hurting yourself and others. And this brilliantly illustrates the other path on the right side, education with morality. The idea here is that when you take that sharp, educated mind and pair it with a strong moral foundation, it leads to true peace of mind and the ability to make consistently wise choices in your life.
This entire curriculum intertwines biblical morality with education for a very specific reason. As the source notes, Romans chapter 8, verses 6 and 7 promises peace of mind to everyone who keeps their mind spiritual. The philosophy here is that when we engage with learning, whether we're talking about physics, history, or literature, through a lens of spiritual wisdom, we aren't just gaining cold, hard facts. We're gaining a peaceful, anchored understanding of our place in the world. It's all about learning to calculate our steps carefully in life, much like we just calculated the motion of objects.
I want to leave you with this final, genuinely powerful question from the source text to think about long after this explainer ends. What is the point of being smart and supposedly educated if we continue to make choices that hurt? Knowledge is power, absolutely. But just like the physical force we studied today, that power needs to be directed wisely. Thank you so much for learning with me today. Keep calculating carefully, keep seeking wisdom, and I will see you in the next explainer.